Okay, let's take a look at question 2. So this is question 2. Right, you are asked to determine the first 3 terms in the series solution for essentially the wave equation, right? And you are given the boundary conditions as well as the initial conditions. Okay, you are asked to use C equals to 200 in your answer. Okay, so let me summarize the question. Okay, so we are doing question 2. Okay. It's a wave equation, okay, and you are given boundary conditions, okay, you are given 2 boundary conditions. So let me call it boundary condition 1, which tells you that u at x equals to 0 at any time is 0, and you also have boundary condition 2, which tells you u at x equals to 2 at any time is also equals to 0, right? And you're also given initial conditions. Okay, now the first initial condition tells you that at time equals to 0, right? At time equals to 0, your u is equals to 0.1. X for x between 0 and 1, and u at time equals to 0 is 0.2 minus 0.1 x for x between 1 and 2. Alright, that's the first initial condition. The second initial condition, IC2, it tells you that du dt at time equals to 0 is equals to 0. Alright, okay, so how do we solve this problem? Well, okay, now since it's a wave equation, right, so wave equation tells me that the general solution is given from your formula sheet, right? So this one is the solution to the wave equation. Right, so the formula sheet tells you general solution is u xt is h plus I x j plus kt plus a cos omega x over c plus b sine omega x over c multiplied by c cos omega t plus d sine omega t. Alright, so this is your general solution. Okay, so next we're going to start using the boundary conditions and the initial conditions. Okay, so we're going to start with the first boundary condition, which is boundary condition 1. Okay. So we put boundary condition 1, which is u at x equals to 0 is equal to 0 into the general solution, into 1. Now that gives us, okay, so all I'm going to do is just put x equals to 0 here, here, and here. Okay, alright, so that gives me h plus 0I, right? J plus kt plus a cos 0 plus b, okay, so x is 0, is b sine 0, now times c cos omega t plus d sine omega t. Now that is equals to 0. Alright, so sine 0 is 0, so this term goes away. Now cos 0 is equals to 1. Alright, so what you get is that h j plus kt. Alright, so a times 1 is just a, so we have a, this term goes away, times c cos omega t plus d sine omega t is equals to 0. Alright, now the important thing here to note is that this boundary condition tells you that u at x equals to 0 must be 0 at any time. Okay, so this is at all values of t. Okay, so the t here can be changing. Alright, so how do you ensure that the left hand side of this is always equals to 0 regardless of the value of t? Alright, of course one way is to have h equals to 0 and a equals to 0, right? So if h and a are equals to 0, you can see that regardless of what value of t you put in here, okay, the left hand side will always be equals to 0, and that's what we want. Okay, now you can also say that why don't we make j, k, c and d equals to 0, right? If j, k, c and d are equals to 0, then the left hand side will always be 0 regardless of the value of t, right? So yes, that's possible, but if you make j, k, c and d equals to 0, look what happens to your solution. J, k equals to 0 means this whole term is 0. C, d equal to 0 means this whole term is 0, right? So it means that your solution is just u equals to 0. Right? U at any x and any t equals 0. So that is a kind of a useless solution, okay, a zero solution, right? That's not what we want, right? So we will stick with h equals 0 and a equals 0 because at least we still have something left. Right? So we put this into equation 1, so therefore your general solution 1 will then become u xt. Okay, so we now have h is 0 and we have a equals 0. These two terms are gone. Right? So this just become I x j plus kt plus b, okay, sine omega x over c times c cos omega t plus d sine omega t. Okay, I'm going to bring the I inside, so this becomes x ij plus I kt plus, I'm going to bring the b inside, so this becomes sine omega x over c, so this b c cos omega t plus bd sine omega t. Alright? Okay, I'm going to call this I times j, I'm going to give it a new name. I'm going to call it j prime. I times k, I'm going to call it k prime. Right? And b times c, I'm going to call it c prime. And b times d, I'm going to call it d prime. Okay? So then this then gives me u, okay, my new solution is x j prime plus k prime t plus sine omega x over c, c prime cos omega t plus d prime sine omega t. Okay, so now I've simplified my solution, equation 1 to equation 2. Okay, and I've done this by applying my first boundary condition. boundary condition 1. Right? So my next step is then to apply boundary condition 2. Okay? So I'm going to apply boundary condition 2 into my new solution. Okay? So let me do that on next piece of paper. Okay. Okay. So what I'm going to do is, I'm going to say, I'm going to put boundary condition 2, okay, which is u at x equals to 2 at any time is equals to 0 into my new solution. Okay, into my new solution. This one, equation 2. Okay. Okay, and what does that give me? Well, so x here now becomes 2, so we get 2 j prime plus k prime t plus sine omega x becomes 2 omega over c prime cos omega t plus d prime sine omega t, right? And then this must be equal to 0. Okay? Now same thing, this has to be equal to 0 at all values of t. Okay? So how do you make the left hand side here be equals to 0 at all values of t? Okay? So you can see, to make this term equal to 0, you need your j prime to be 0 and you need your k prime to be 0. Okay? So your j prime and k prime are equal to 0 already. Now to make this term to be 0, you can say, you can make c prime equals to 0 and d prime equals to 0 as well. But if you do that, you can now take a look at the solution, okay, that you have obtained so far. If j prime is 0, k prime is 0, if c prime and d prime are also 0, again, you end up with your solution u being 0. That's again not what we want. Okay? So if you look closely at this term, okay, to make this term equal to 0, there's another way. Okay? The other way is to have sine 2 omega over c to be equals to 0. Okay. Now, sine 2 omega c equals to 0 will then mean that your 2 omega over c must be some multiple of pi, r pi, right? So r is now 1, 2, 3, any number. Alright? Okay. So then that tells you that you have many values of omega. Okay? So omega is just r pi c over 2. Alright? Okay, so now that you have this, let me remind you in the question. Okay? In the question, you are told to use the small c, this small c is equals to 200. Okay? So you know that your omega is now just 50 r pi. R equals to 1, 2, 3. Okay? So now I know this is 0, this is 0, and my omega, okay, is equals to this. Okay, I'm going to put all this back into my solution, which is my equation 2. Okay? My equation 2. Okay? So what I'm going to do is, I'm going to put j prime equals to 0, k prime equals to 0, and omega equals to 50 r pi, okay, into equation 2. Okay? This equation. let's see what we get. So this means that my u, the new solution, right? So this term is gone, right? K prime and K prime are 0, so no more. Right? So what we have here is sine. Okay, so omega is now 50r pi. Alright. Remember what C is, okay? Right. C is $200, right? C is 200. Okay. Okay, so now we have sine omega is 50r pi x okay, 50 divided by 200 is 4, right? Okay, let me just check that I didn't make any mistake. Sine 50 divided by 200 is 4, so we have oh, sorry, I made a mistake here. C is 200, so 200 divided by 2 is, this is 100. Sorry, mistake here. 100. This is 100. Okay. So maybe there's a mistake here. Okay, so this means that u at x plus t is, so it's sine r pi over 2x, right? Okay, yeah. Okay. Then you have c prime cos omega t. So omega is 100 r pi. So you have cos 100 r pi t plus d prime sine 100 r pi t. Okay. Now remember what I told you in class, right? So now you can see that your r is 1, 2, 3, right? Okay. So you have many values of omega. So every value of r inside here gives you a solution. Remember what we talked about in class? If I have many different solutions, when I sum them all up, it's also a solution, right? So when we reach this stage, the solution that we want is not r equals to 1 or r equals to 2 or r equals to 3. We want everything, okay? So basically we want to do a sum. We want to sum up all the solutions 1 to infinity, and each solution will have its own coefficient of r prime and d prime. Okay, so now you can see we have now reached a new solution, okay, which let me call this solution 3, right? So we have further simplified solution 2 to solution 3. Okay, so this is the solution that we need. The only thing that's left is we need to find the coefficients c prime and d prime r. Okay, now how do we do that? If you look at your original question, okay, you have used up the boundary conditions, and 1 and 2, you have two initial conditions, initial condition 1 and initial condition 2. Now you can see that initial condition 2 requires you to do a du dt. Okay, so I'm going to find a du dt here. Alright, so I found u. So now I can find what is du dt. Okay. Right, so I'm going to just differentiate with respect to t. Okay. The sine pi x. Okay, this has no t, you don't need to differentiate. Now look at the term inside. You'll find that when you differentiate this cos something t term, you will just get minus, right? 100 r pi cr prime sine. 100 r pi t, and when you differentiate sine, you get cosine. So it's plus 100 r pi dr prime sine, cosine 100 r pi t. Okay, so there we go. Okay, so more work to be done. Okay, so what I'm going to do now is I'm going to start applying the two initial conditions, right? I've already done BC1, BC2. Now I'm going to start with initial condition 2 first, okay, because this is easier. This is equals to 0. Okay, so what I'm going to do now is I have now these two equations, 3 and 4. Okay, so I'm going to put my initial condition 2. So I'm going to put initial condition 2, which is du dt, okay, at time equals to 0, okay, is equals to 0, right? So I'm just copying this from the question. Okay, take a look at the question again. Alright, this is the question. So I'm just copying this initial condition. Alright, and I'm going to put this into the equation that we just formed, equation 4. Into equation 4. Alright, so what does that give me? Okay, so I'm just going to put t equals to 0. Right, so you have sine r pi x over 2. Alright, so this is just going to be minus 100 r pi cr prime sine 0, right? T is 0, so sine 0 plus 100 r pi dr prime cos t is 0, so cos 0. Okay, and this must be equals to 0. Right? This is one of the initial conditions. This must be equal to 0. So again, sine 0 is 0, cos 0 is 1. Okay, so what we are left with is, just get summation. Okay, so you have, I'm going to bring out this, I'm just going to copy this term first. 100 r pi d prime r, cos 0 is 1, so I don't have to write it down. Don't forget to have one more term here, sine r pi x over 2 must be 0, okay? And this must be 0 for all values of x. Okay? So how do you make the left hand side equals to 0 regardless of the value of x? Okay? So there's no choice. Okay? It just means that your DRs have to be 0. Okay? So if your dr is equal to 0, you can now see what happens to your solution. Okay? The solution is, remember what's the solution? Equation 3. Okay? So you put your dr prime equal to 0 into your solution. So you put dr prime equals to 0 into your solution. Okay, your latest solution is 3, and what do you get? Okay, you basically mean that this term is 0, so you're only left with this term. Okay, so it means that your new solution now, your updated solution now, is simply this. Okay, I'm going to bring the CR prime to the front. Prime sine r pi x over 2 cos 100 r pi t. Okay, so this is your new solution. Okay, so I found dr prime to be 0 already, once I found what CR prime is, that's my solution. Okay. Alright, so how do you find CR prime now? Okay, to find CR prime, you have one more information that you have not used in your question 2, and that is your initial condition 1. Okay, now this one will give you what CR prime is. Okay, so as usual, I'm going to put initial condition 1. Okay, so I'm going to put initial condition 1, which tells me that u at t equals to 0 equals to some function. Okay, let me just call this fx. Okay, and fx is defined like that. Okay, so you can see it's just a function of x, 0.1x or 0.2 minus 0.1x. Okay, so I'm going to put this into my latest solution, which is equation 5. Okay, right, equation 5. That's my latest solution. Right, and what does that give me? Well, that just gives me, so I put t equals to 0 here. Right, so I'm going to put t equals to 0 here. That's CR prime sine r pi x over 2. T is 0, so this just becomes cos 0. Okay, and this must be equals to fx. Okay, and fx is defined here. Okay, now what's cos 0 again? So again, cos 0 is equals to 1. Okay, so this means that you have this r pi x over 2 is equals to fx. Right? So I hope you remember what this means. This is a sine series expansion of fx. Okay, right, with L equals to 2. Remember, L is half the period, right? So your function fx is defined from 0 to 2. Okay, so now you know how to find. So this is like your BR in sine series. Okay, so this tells you that you can find your CR prime just like you find BR in sine series, which is simply 2 over L 0 to L fx sine r pi x over L dx. Okay, where L is equals to 2. Alright, so this becomes 2 over 2, 0 to 2, fx times sine r pi x over 2 dx. Alright, and because your fx is defined differently from x between 0 and 1 and 1 and 2, you now have to split up the integration. Right? So this is equals to 1. So I'm going to split up the integration here. So it becomes 0 to 1. From 0 to 1, my fx is 0.1x. So it's 0.1x multiplied by sine r pi x over 2 dx. Okay, plus, and then, so I split this integration from 0 to 2 into 2 integrations, one from 0 to 1 and the other is from 1 to 2. And from 1 to 2, my fx is 0.2 minus 0.1x. is 0.2 minus 0.1x. Okay, multiply by sine r pi x over 2 dx. Okay, so you do your integration. I'm not going to do the integration. Alright, after you do the integration, you will find that your CR is going to work out to 0.8 r squared pi squared sine r pi over 2. Okay, now with that you can then see that you will find that C1 is 0.8 over pi squared, and then you will find that C2 is 0. Okay, you will find that C3 is equals to minus 0.89 over 9 pi squared. Okay, so you just put r equals to 3 into here to get C3. You will get C4 equals to 0, and C5 is equals to 0.8 over, so you put 5 inside here is 25, so it's 25 pi squared, and so on. Okay, so the question asks for the first 3 non-zero terms. Okay, so we have this. Okay, and therefore the first 3 non-zero terms are, okay, alright, so you just remember where's the solution. Don't forget which one is the solution. Your solution is equation 5. Okay, this one. Alright, so this one. So you put these values of C1, C2, C3, C4, and C5 into here, right? You want the first 3 non-zero terms, means your C1, C3, and C5 terms. Okay, because your C2 and C4 terms are 0. Okay, and you can see that that will actually give you the answer to the question. U is equals to 0.8 over pi squared. Okay, the common thing inside here, sine this okay, this is your C3 term. And finally your C5 term. Okay, so this is actually given to you as the answer. Okay, okay. Now this from equation 5. Okay, this one, equation 5. Alright, so that's question 2. So question 2 is a pretty long question.